Hi guys and welcome. If you ever paid attention to the weather report, you've probably heard the weatherman talk about how a low pressure system is approaching, so get ready for some rainy and windy weather. Or, this high pressure system means we'll have some nice weather installed over the next couple of days. But why are high pressure systems associated with warm, sunny weather and low pressure systems associated with low temperatures and stormy weather? Firstly, we need to understand how the gases in our atmosphere move about our Earth. The air all around us is in constant motion. Through the sun's rays unevenly heating up the Earth's surface, to the ocean and land wind currents, rotation speeds from the poles to the equators, which causes what is known as the Coriolis effect, the way in which air moves in a low pressure system. And a whole lot more all come together to play effect to the weather. Gases, or air particles, can also move through heating up and cooling down. When gases are heating up, they rise, and when they cool down, they fall, which a lot of us already probably know, but what not many of us would know is why. Basically, it is because when gas particles are heated up, they expand in volume, reducing the overall density, and less dense objects want to float. This can be modelled through Charles's law, which states that V1 over T1 equals V2 over T2. Charles's law states the volume in litres of a fixed mass of any gas is directly proportional to the temperature in Kelvin, where only the volume and temperature are allowed to change. Let's put this into an example calculation using Charles's law. If I have two balloons, and we won't worry about the mass and elastic properties of the balloons to maintain our constants. Let's say the pressure remains the same. But I have two balloons, and in one balloon I blow 1 litre of, and the temperature of the air is 25 degrees, and we needed to convert this to Kelvin. To do that, we add 273 to our figure in Celsius. And then we heat up our balloon, so now our new volume is what we don't know, and our new temperature is 35 plus 273 to convert to Kelvin. Now how do we tackle this question? So Charles's law states that V1 over T1 equals V2 over T2. Now what we do is we sub in what we've already know over here into this equation. So we've subbed those in, and the V2 is what we need to know. So how do we work this out? So we times both sides by 308 to get V2 by itself. So there we go, we've got 1 over 298 times 308 equals our V2. And our V2 is 1.034 litres. So now we have to do the same thing, but this time we're going to heat the balloon. So we've got our V1 equals a litre still, and our T1 is 25 degrees, or 273 plus 25 to convert into Kelvin. Our V2 is our unknown, that's what we're going to work out, and our T2 is 273 plus 15 degrees, since we've cooled it down now. So we sub in all our points again. So now we've got 1 litre over 298 Kelvin equals our V2, or our unknown, divided by 288 Kelvin. So we just do the same again, 1 over 298, this time times by 288 to give us our V2 of 0.966 litres. So what's happening here? Well, I still have the same amount of matter inside each of my balloons, but as it states in Charles's law, volume and temperature are proportionate to each other. So when I heat the air up, the particles inside get more energy, so they speed up, and from that, the volume of the particles increases. Unlike when I cool particles inside the second balloon, the particles become slower and move about less often. This change in volume creates a change in density. Now this is density here. So if my mass, which is not changing, but as my volume increases, then the overall density is going to go down. And if my volume decreases, the overall density will go up. So as the warm balloon has more volume for the same amount of mass, it is less dense than the cold balloon. The less dense objects, the more it wants to rise. Just like a piece of wood will float on top of water, and a rock will sink. The wood is less dense than the water, but the rock is more dense than the water. If I was to combine the hot air balloon, the air inside the hot balloon, and the air inside the cold balloon, we would expect to see the cold air sink to the bottom and the hot air rise. Like shown here, we'll have the hot air up the top and the much denser cold air down the bottom. What does this mean when relating it to low and high pressure systems? Well, when the air on the surface heats up, it rises quickly, leading to low pressure at the Earth's surface. As this warm air rises, it begins to cool down quickly. When the air cools, it condenses, which can be modelled through the combined gas law this time, as the pressure is changing. The temperature goes down while the pressure goes up. So does the volume. These cooler temps cause the water vapour in the air to turn into liquid, forming clouds and unsettling weather. And in a high pressure system, the air cools and moves downward, leading to high pressure at the surface. As this air moves downward, it heats up, increasing the volume, becoming less dense. This dry air at the surface creates clear and stable weather conditions. So next time you're watching TV and the weather report comes on, you can appreciate what gas laws do for us and predicting weather. Thanks for watching. Hope you learned something.